let's look at solving radical inequalities. Now, before we get to that, let's think a little bit about radicals. And so I want to think about square root, anything with an even index. Let's look at the square root of x. So first of all, knowing about the square root of x, I want to think about the domain. What x values can we plug in or cannot plug in? And so for here, what x values can we plug in? Can we plug in anything we want? We cannot. So we know that what's inside the radical must be positive. So therefore we know that the domain has to be 0 to infinity in this case. We can think about that graphically when we graph the square root of x. Remember, it looks like this. I call it half a rainbow. So we know that it stops at 0, 0, and it can't go beyond that. So the same is true for an inequality. For an inequality, we're saying, x has to be some value. And so say, for instance, we say it's less than 2, less than or equal to 2. Well, if we're looking at something that's being plugged in here, we cannot plug in every single number that's less than 2. In this case, the lowest number we can plug in would be 0, right? The lowest number we could plug in is 0. And so we have to think about our restrictions. Okay, and so I'll show you how to solve for those restrictions, but this is only for the even index. Now thinking about a cube root, for example, cube root, are there any restrictions there? Our domain, what is our domain? Domain for a cube root is negative infinity to infinity. If you think about the graph, it goes on forever. So there was no restriction for cube root, so it's only for our square root. So there's like 3 different examples that we could see, and we're going to see it here to kind of help us out. One more thing about inequalities is that with inequalities, you have to remember when you're solving for it, you have to remember a certain rule. So for example, if you have negative 3x is less than 12, remember if you divide by a negative, you have to flip the inequality in order for it to be true. Okay, so just kind of a little thing that we need to remember. When you multiply or divide by a negative, it has to be, you have to flip the inequality. So let's solve for this very first equation. We have 3 square root of x minus 1 is less than or equal to 12. We have to solve it like we normally do a radical equation. So we divide by 3. We want to isolate the radical. So we have x minus 1 is less than or equal to 4. Then to get rid of the square root, we square both sides. So now we have x minus 1 is less than or equal to 16. Then we add 1 to both sides. So we see that x is less than or equal to 17. Now looking inside the radical here, we have the square root of x minus 1. So let's just look at the square root of x minus 1 first of all. Can we plug in any number we want in here? Now if you say yes, let's pick negative 30. If you say I can pick any x value I want. So I plug in negative 30 minus 1, I get a negative 31. Now remember with the square root, you're not allowed to have negatives in there. And so it is not true that I can have anything I want. So we need to restrict it. We have to look at what is the lowest x value we can plug in. Now another way to kind of think about this is you want to think about using the zero product property. We can make it 0, but it can't go below 0. So what I'm going to do is I'm going to solve for it, solve for inside here. So I'm going to say that the x minus 1 here, x minus 1, it has to be greater than or equal to 0, right? That is our restriction. We talked about it here. It has to be positive. So x minus 1 is greater than or equal to 0. We're solving for inside the radical. You solve for it, you get x, you add 1 to both sides. X has to be greater than or equal to 1. Now to prove it to you, if I plug in 1 into this inequality, 1 minus 1 is 0. And square root of 0 is 0. So 3 times 0 is 0, and that's less than or equal to 12, which is true. Now if I plugged in, let's just plug in 0. So 3 square root of 0 minus 1. I hope you see that doesn't work, because you get a square root of negative 1. That's I, right? It's imaginary, so that's not allowed. So we see that 1 is the lowest number we can plug in. So that is our restriction. So now in order to write this completely, so this is only partially correct, to make it completely correct, we need to write this restriction here. The lowest the x value can be is a positive 1. So notice that the mouth here is open to the x, so it's still going to be open to the x here, and then 1 to the left of that. So x has to be between 1 and 17 in order to make this inequality true. So I want you to go ahead and try letter A, 11A, 11B, and then number 13. And 11A and 11B are actually two different types of examples. And so just see what you get, and then we'll talk about it. All right, let's take a look. 11A, you should have gotten x is greater than or equal to 9. So look at the work here. You add 3 to both sides, then you divide by 2, you square both sides, so x is greater than or equal to 9. Now there is no restriction here. X is greater than or equal to 9. So let's just look at a number line real quick. So it's saying that I can pick any number that's 9 and greater. Now let's look at the restriction in here. So square root of x, what's the lowest number we can plug in there? 0 is the lowest number we can plug in. Square root is 0, right? So 0, and it has to be greater than that. And so notice that my answer, my x is greater than or equal to 9, will never hit this 0. So it doesn't matter. I don't need to say that x has to be greater than 0 because it is already greater than 0. So that's not necessary. Okay, it's never going to hit below. It's never going to be negative because I'm picking 9, 10, 11, 12. Okay, 11b, this is x is less than 7. Divide by 4 first. You cube both sides and get x is less than 7. Now, because it's a cube root, therefore, there is no restriction. It goes forever. The domain is infinity, negative infinity to infinity. So therefore, it can be less than 7. We can have negatives, and that's acceptable. Number 13, there's a little work in that. So number 13 is a nice problem. Number 13, you have to subtract 3 first. And so you get negative 4 square root of x minus 1 is greater than or equal to negative 4. You divide by a negative 4. And you remember, you have to flip the inequality because you divided by a negative. So therefore, you have the square root of x minus 1 is less than or equal to 1. Then you square both sides. So you get x minus 1 is less than or equal to 1. Then you add 1 to both sides, 1 plus 1. So you get that x is less than or equal to 2. So that's where I stopped there with the purple. Then I had to think about my restriction. X, it says that x can be less than or equal to 2, right? I can go anywhere here. Now let's think about our restriction. Let's think about just the square root of x minus 1. So in there, I cannot have any number that we want, right? I can't pick like negative 10. I'm going to get a negative number in there. So we have to solve for it. So that's what I did here. So I just take what's inside the square root, and I set it greater than or equal to 0. Then I solve for x. So x has to be greater than or equal to 1. So the lowest that x can be is a positive 1. So because of that, we have to say that x has to be between the 1 and the 2. Okay, and so that's the final answer.